Third class of visualization of 3D objects. Today we'll be studying about the counting blocks in 3D composition. So let's look about it. Again, this topic in which you need to count the blocks in any 3D composition, any given composition, this is also important for your NATA perspective. It is actually important for both the exams. The reason being, again, this is a subtopic from the visualization part. So from this particular subtopic, you can expect 1 to 2 or even 3 questions also on an average in each exam. So this way, this weightage makes it important for the exam point of view. And in this particular topic, that is the counting blocks, we need to understand the 3D objects. And the arrangement of blocks in it. Basically, remember in the previous class, we studied about different objects, those mathematical objects, the cube, cuboid, tetrahedron, or anything. In your counting blocks, you will majorly be getting only a cube or a cuboid. These will be arranged one over the other or in any kind of arrangement. So there would be an arrangement of blocks. You need to understand that arrangement that is making it this 3D object. And then after this understanding of the arrangement, you need to count them. Count the blocks. Of counting blocks part, you will be given some 3D object. There would be some arrangement of blocks that is making the 3D, and then you need to count the block. So if we get into a little more detail, like in the counting surfaces part, there you are counting the surfaces, the edges, the vertices, and the faces. So there were two options. Either the 3D object will be given to you, or only the name will be given to you, and you need to identify through the name like which 3D object it is, and then you need to count all the requirements, right? In this one, in the counting blocks part, there won't be any, you can say, statement kind of question. There will always be an arrangement of blocks that would be given to you. So we can say the 3D object will be given. Now, when I say this 3D object, it is actually not one object. It is basically the arrangement of different, like this one that you are seeing here. So this is a 3D object. This is a 3D object, but we are talking about them collectively. So our 3D object is basically such kind of arrangement, a stacking of these different cubes. Now, there are certain things that you need to keep in mind while analyzing such arrangements. So the first one is that you need to be careful about the cubes which are not visible to you. It's not always that all the cubes would be directly visible to you. It's like if you see this arrangement, so this is one view of the total arrangement. You can get another view from this side, or you can get some view from this side, but only one view would be given in the question. So you should be careful about the cubes which are not visible to you. That is, we see this is a green block. A smaller green block is also visible at the base of it. And then we would be having one more green block at the base of it. That green block is not visible to you, but you need to assume that it exists there. Clear? So you
Yes,
need,
sir.
okay, so you need to always observe the plan and the relative position of objects. There won't be like this is a 3D object and then you would be having some kind of block which is sitting completely separately from this arrangement. There won't be such kind of questions. That means all the blocks would be interconnected. So in our list of things to keep in mind, first is carefully observe the hidden blocks. Second is all the blocks would be interconnected. It's like this small block that you are seeing here, this one. This block exists because this block is connected to the rest of the figure. Clear? So therefore we would be having this block, then one block on this side, then these two blocks, this one, these green blocks, one more on the base, and then these four blocks. This would be the overall layout. So quickly confirm if things till now are clear to you. All these two
Yes, sir.
slides. Others also please confirm. Either write in the chat box or simply unmute yourself. So the next thing is the method of solution, like how to solve them. Now in this, we can say we have total three methods. First method is just you simply start counting. You can even write in bracket that randomly. Means you might think that, okay, there would be some simple arrangement, this kind of composition. I'll just start counting 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, like that. So this is one method in which there are a lot of chances to miss out. Like I just counted 1, 2, 3, 4, 5, 6, and then I said 7, 8, 9. That means I missed the block that was behind it, right? So this way, even if you prefer to just simply start counting, you need to be careful about the blocks that are hidden. So that was the first method. Then let's talk about second method, and that is about grouping. This grouping part is also on the base of counting, like you start counting things, but it makes it a bit easier for you. Like you have this 3D, you consider this as one group, you consider this as second group. So you count for the first group, let's say anything like 6, then you count for the other group, say 7, you add them. If you have some more groups, you count for the number of cubes in that group also. And this way you give your answer. So this was a method of grouping in which you simply break down any complex arrangement into smaller groups, and then your task is simply counting in those smaller groups. Then we have the third method, and this method we can say count via row or column. This method is actually very efficient, and what happens in this, you mark the number of rows or columns, whatever you want to say. Like in this, let's say these are the 3 columns, right? So I just mark the columns 1, 2, 3. I first observe the 3D and I look at the columns which are identical. These three are identical, so I have marked them 1, 2, 3. Then I count the number of blocks in each of them. So those are 1, 2, 3, 4, 5. So this way, the number of cubes in first one is 5 multiplied by 3. Then you look at the next part. So you add. So you see, you can also use these two things together. You are doing the grouping and you are counting via rows and columns. Then we take this 1, 2, 3, and they are having 1, 2, 3. So we are having 3 columns with 3 blocks each, like that. And then we are having these 1, 2. So 2 into 1. You simply multiply them, you add them, you will get the total number of blocks in this particular composition. So you can say number of cubes would be equal to number of columns, like these columns, multiplied by the number of cubes in any one column. Quickly tell me if the things on this slide are clear to you or not.
Yes, sir, understood.
Understood? Because try those who are still struggling to understand this, please stress upon this method because it will make it very easy for you to simply count the number of blocks. I'll show you some complex arrangements also. And if you just simply think of, start counting the blocks, then this method will make it difficult for you. So I want confirmation from other students as well, if things are clear to or not.
Yes, clear, sir.
Okay, thank you. And some new students who have joined us in today's class, but they were not in the previous one. Are you guys comfortable till now in the class? Vishal, Vishakha? Are you guys still with us? Okay, thank you. So with this understanding till now, we have looked at the importance of these blocks, what kind of things could be given in the question and how to solve them. Only this much of the concept was there in counting blocks. So after this, we can just simply start solving the questions. So count the number of blocks for me in this arrangement.
4.
Okay.
Option B.
So option B.
Yes. Remember always to answer like option A, option B, that way.
Sorry, sir.
That's okay. You can take care of it from the next time. So this way, it's clear that you guys have taken into consideration the block that is not visible to us, that exists here. Also, the arrangement would be only like this, that okay, there the block should be here. There won't be any additional block on the back side. Remember that. Do not start imagining by your own that we might have any such block on the opposite side also. Keep that in mind. There would be only blocks in continuation. Then count the number of blocks in this.